So let me summarize the key findings of the latest IPCC report. It is unequivocal that human influence has warmed the atmosphere, ocean and land. Widespread and rapid changes in the atmosphere, ocean, the cryosphere and the biosphere have occurred. Okay, here's the evidence shown on the left side. Changes in global surface temperature relative to the average between 1850 and 1900. And you can see on the left side a time series over more than 2,000 years of temperature variation reconstructed, okay? Reconstructed from using different type of methods and directly observed at the end. And you can see that the temperature was relatively steady over the 2,000 years, and then there was a slight cooling and just before the rapid human-induced warming that we're experiencing, with anomalies exceeding 1 degree Celsius as a global average. Okay, you can also compare that with the warmest multi-century period in more than 100,000 years, and indeed you can get the maximum as 1 degree, and so we're at that same level, even higher. Okay. On the right hand side, there's the central argument, okay, that it's actually due to human-induced greenhouse gas emissions, is you can recalculate temperature variations using computer-based models, okay, and you can compare it with observations, and then you can switch off or keep CO2 constant. You know, no human-induced emissions, and you can see the difference. You know, you can see the difference. Without the human-induced greenhouse gases, the temperature would have stayed relatively stable. Okay, so it's because of the human influences. Okay, greenhouse gases. Okay, observed increases in well-mixed greenhouse gas concentrations since around 1750 are unequivocally caused by human activities. And you can see here the graphs for CO2, okay, and for methane and for nitrous oxide. Okay, you can see sharp increases of these concentrations of these greenhouse gas emissions. You can see the values are written here. Okay, all right. So land and ocean have taken up a near constant proportion of CO2 emissions, globally about 56% per year, okay, from human activities over the past 6 decades, with regional differences. And there's high confidence, so we can measure this, okay? And indeed, and that's what you learned, that this uptake has actually mitigated the global warming effect, okay, because so much CO2 has ended up in the ocean, has been absorbed on land, okay, so this has actually reduced the extra CO2 in the atmosphere. Alrighty, precipitation is a little bit less certain, okay, and we can have a look here at this figure first above my head. Okay, so global precipitation, okay, anomalies in millimeters per day, okay, and from 1950 to about 2015, and again done with a model which only includes natural effects, and a model which includes anthropogenic effects. And you can see that there's a slight increase in the end. Okay, So globally, average precipitation over land has likely increased since 1950, with a faster rate of increase since the 1980s. This is medium confidence. It's likely that human influence contributed to the pattern of observed precipitation changes since the mid-20th century. Okay? I'd just like to add that mid-latitude storm tracks have likely shifted poleward in both hemispheres since the 1980s with marked seasonality in trends. Some medium confidence in that. Okay, so we don't, there are observed changes in precipitation patterns. The cryosphere, the ice system. Okay. Human influence is very likely the main driver of the global retreat of glaciers since the 1990s and the decrease in Arctic sea ice area between 1979 and 1988 and 2010 to 2019. Decreases of about 40% in September and about 10% in March, and it shows you the observed trend in Arctic sea ice. Okay. Antarctic sea ice is more difficult to understand. Okay, it's in a more remote region. Okay, in terms of exposure to global wind and weather patterns. Okay, and I've discussed this in the lecture, but there has been no significant trend in Arctic sea ice from 1979 to 2020 due to regionally opposing trends and large internal variability. However, more recently there has been a very strong variability with a strong decline and then an increase. Okay, and in 2023 it actually was the lowest ice coverage ever recorded. So watch out in the near future what happens to the Antarctic sea ice. So human influence very likely contributed to the decrease in Northern Hemisphere spring snow cover since 1950. And it's very likely that human influence has contributed to the observed surface melting of the Greenland ice sheet over the past 2 decades. Okay, the ocean features. Okay, let's have a look first at the ocean warming. So it's virtually certain that the global upper ocean has warmed since the 1970s and extremely likely that human influence is the main driver. Okay, on the right side we actually see a reconstruction of the heat content of the ocean from the surface to 2,000 meters from 2000 to 2020, and you can see that increase. Okay, and this has been derived on the basis of so-called Argo floats, which are autonomous measuring devices that measure temperature profiles in the oceans. Okay. It's virtually certain that human-caused CO2 emissions are the main driver of current global acidification of the surface open ocean. Okay, and I've talked about the details of that. All right. Okay, just for completeness, this graph uses a unit of zettajoule, and zetta means 10 to the power of 21. There's a high confidence that oxygen levels have dropped in many upper ocean regions since the mid-20th century, and medium confidence that human influence contributed to this drop. And it's a tricky field to understand what causes oxygen reductions in the ocean. So I haven't discussed that in great detail in this lecture, in the lectures of this topic. Anyway. So let's look at the sea level. Okay. So global mean sea level increased by 20 centimeters between 1901 and 2018. The average rate of sea level rise was 1.3 millimeters per year between 1901 and 1971, increasing to 1.9 millimeters per year between 1971 and 2006, and further increasing to 3.7 millimeters per year between 2006 and 2018 with a high confidence. Okay? And we know that from reconstruction of sea level changes from tide gauges corrected for post-glacial rebound features and satellite observations. Human influence was very likely the main driver of these increases since at least 1971. Okay, and these figures indicate that there is an increasing rate of sea level rise. Okay, it's accelerating. And above my head, you can see a graph that shows you the sea level, the observed sea level rise from 1970. And some of these details are estimated, but that's the best scientific knowledge that we have. And you can see that the ocean, from 0 to 700 meters and below 700 meters plays a big role. This is due to the thermal expansion. Okay. And the melting of ice that actually sits on land, and then the meltwater ends up in the ocean. That leads to sea level rise and has contributions from glaciers, from Greenland, from Antarctica, and then there's some other influences from land water storage. All right, you can see that there are sort of all these contributions, and they all contribute to the observed sea level rise. Okay. And indeed, this is very concerning. Land biosphere. Okay. Changes in the land biosphere since 1970 are consistent with global warming. Climate zones have shifted poleward in both hemispheres, and the growing season has on average lengthened by up to 2 days per decade since the 1950s in the northern hemisphere extratropics with a high confidence. Okay, and indeed feel free to look up these details, to study these details in the 6th IPCC assessment report, but it is a beast. It has many, many, many pages. All right, and I tried my best to just summarize the key parts of that. Okay. All right, some study questions. Okay. All right. So what are the key principles of the scientific method? Tell me, what are the key principles? Does the IPCC undertake scientific research? Do they actually do modeling, the IPCC people? How does the IPCC define confidence levels? How does the IPCC define probability levels? So your neighbor comes, hey, what are actually the key findings of the 6th IPCC assessment report? Tell me, what are the key findings? Well, who's responsible for the observed climate change? Is there anything we can do to stop it? What do we need to do? So thanks for watching.